In the last class, we discussed jet propulsion system and we covered these three air breathing propulsion systems, that is screw propeller, ramjet and pulsejet. And today we'll discuss about turbojet and turboprop, as well as the liquid propellant and solid propellant under rocket propulsion. Before going to turbojet and turboprop, let me recap about the three other propeller that we discussed in the last class. So we discussed in the last class that a jet engine, jet propulsion principle is like a balloon filled with air. Suppose a balloon filled with air is with us and we open the mouth of the balloon, and in that case what will happen? The air filled inside the balloon will escape from the mouth, and that is the stream or jet of air, and that is the active force. And because of the reactive force, the balloon is supposed to move in the forward direction, and in place of balloon you just imagine the vehicle or the jet engine, aircraft engine. So if that is so, in case of a balloon, if the air escapes, it will go a few distance, but after that there is not enough air to continue that thrust. So the thrust is in the forward direction, this direction. So in such case, what we need is continuous high pressure gas inside the balloon or vehicle, so that continuously it can move forward. In a jet engine, thrust is the force produced by an engine in the forward direction. If we have to get the continuous thrust, consistent thrust, then we should ensure the supply of high pressure, high temperature gas inside the balloon, or in place of balloon you just imagine the vehicle, whatever vehicle we are talking about, that is the jet engine. So in case of a balloon, the air will escape and balloon will move forward, but after that this movement is not consistent, it will stop. So we need a consistent supply of high pressure gases. So let's see how it can be imagined. So inside the balloon or the vehicle, we need one compressor which will supply the compressed air, and air will enter into the combustion chamber where the fuel will be burned, and that will increase the temperature even more. And after that it will enter into the turbine. After compressor it will enter into the turbine, and turbine will produce the power. And if the product of combustion is allowed to go through this balloon or the vehicle at the rear end, then this is the active force, and this active force will produce the thrust in the forward direction, and that is the working principle of a jet engine. And that is why the jet engine, the name is jet, that means this is jet of fluid passing through a nozzle. So if we can ensure the continuous or consistent high pressure temperature, then we can get the continued movement in the forward direction for the vehicle or for the jet engine. So then only it will move forward continuously, consistently. If we attach one propeller in front of the vehicle, in front of the engine, suppose we attach one propeller. So what is this? This is the propeller. Then what will happen? The turbine will produce the power. A part of the power will be used by the compressor, and the rest of the power will be used by the propeller. And there will be very little amount of energy on the escaping fluid. So in that case, we will call it a screw propeller. If the driving force thrust is only because of propeller, then it is called screw propeller that we discussed in the last class. So in this case it will move with the help of propeller only, and propeller get the power from the turbine. So it will move in the forward direction because of the thrust, and propeller moves and it gets the power from the turbine, and accordingly the vehicle or the aircraft will move. Okay. Now last class we also discussed about the ramjet, and in ramjet there is no moving part like screw propeller. So in this diagram you can see there is no moving part, there is no compressor, there is no turbine. So there is one diffuser, and that ensures the supersonic compression as well as subsonic compression. Now what is a diffuser? In the last class I did not explain anything about diffuser. A diffuser converts the kinetic energy of air to the static pressure. In fact, a compressor also have a diffuser, and because of the diffuser part in the compressor we get high pressure, that means kinetic energy is converted to static pressure. And in this case we will get the kinetic energy because of the forward movement of the jet itself. The jet engine moves forward, and because of that we get the kinetic energy of the air coming inside the body of the jet. And this jet of air or this flow of air is compressed because of the diffusion effect in this region. And this diffusion there may be two diffusers, one is supersonic diffuser and one is subsonic diffuser. So what the diffuser will do? Actually they will compress the air, that will increase the static pressure. Now the pressure is high enough, and in that position if we inject the fuel then it will burn. We may use spark plug or not depending on the situation. So because of the combustion the temperature will increase even more, and this space is for the expansion. So in this case there is no turbine, but expansion takes place in the nozzle. So nozzle is also an expansion device in which the pressure energy is converted to kinetic energy, and this is the flow of jet of hot gases through the nozzle will give very high kinetic energy, and that is why it is called supersonic exhaust, and that will give the forward thrust to the vehicle. Okay, that is the principle of ramjet, and the effect is ram effect. Last class we discussed what is the ram effect. So this way it will move because of this thing. So we are still considering the balloon. In place of balloon you just imagine the vehicle. We are considering that inside the balloon there is some arrangement for continuous or consistent supply of high pressure gases which will escape through the nozzle, and that will give a forward thrust to the vehicle. So the ramjet has some disadvantages, just you have to know the point, and this disadvantage is on the combustion. The combustion is not very good in ramjet, and that is why there are another jet that is called scramjet. Scramjet is nothing but supersonic combustion ramjet, in which the combustion is done in supersonic mode itself. So we need not know more than this, that is more than enough for this subject point of view at this level. Now the ram effect is what? If we try to define the ram effect, it is the compressing effect. So what does a ram effect gives us? It gives us compressed air. How it is obtained? It is obtained by locating the entrance to an air intake duct. So this is the duct in the ramjet. This duct gives that effect, and this is generally in an aeroplane. How it is done? It is increasing the static pressure. So a ram effect is effect in which it passes through a ram body. Around the ram body, this we consider a ram body, and because it decreases the kinetic energy, and increases the pressure energy, which we call the static pressure, because the movement of the air has also the pressure component, but that we call the dynamic pressure. But when the velocity decreases, kinetic energy decreases, then that is converted to static pressure. Okay, in the last class we also discussed about Pulsejet engine, in which there is one effect called the pulse effect. Say, in a Pulsejet engine, what does it do? It employs an ongoing sequence of discrete combustion. In the last class we called it pulse combustion. That means combustion, intermittent combustion. But it is not a sustained combustion. That is not a continuous combustion process. It is a discrete, or we can say intermittent combustion process. So that effect is called the pulse effect. You know what the word pulse means. You know about the pulse polio vaccination program, and that is also intermittent event, and it takes place at a particular date. Again, it is not done continuously. Again, at a day, it is done in the whole nation, whole country is involved in the vaccination program. That means that create a pulse, high intensity effect it can create. So that is the principle. That is why it is called Pulsejet engine. Okay, and in Pulsejet engine, combustion occurs and pressure is built up in the closed combustion region. So this is the closed combustion region. When the combustion takes place, immediately these valves, inlet valves, close, because these are non-return valve. Only it can enter into the combustion chamber. Air can enter into the combustion chamber, but the product of combustion, because of the high pressure, cannot escape this way. But it can escape towards the rear end of the vehicle, that is we call the exhaust through the nozzle, through a tailpipe. So it will go through a tailpipe, and that is the effect. That is the Z, and that is active force, and reactive force is forward, which we call the thrust. Now, today we are coming to the next topic, that is turbojet engine. You look at the terms turbojet. So there will be two effects. One is the jet effect. Definitely jet will be there, and turbo means there will be one turbine. So you can look at the diagram. There are two colors are used. One is green and another is this pink type color. So this is the high pressure compressor. This is high pressure compressor, and this is run by the high pressure turbine. So why do we need compressor? So compressor gives high pressure air to the combustion chamber, and in between this there is a combustion chamber. So combustion will take place in this yellow part, yellow space. It is represented by yellow color. Now there is another turbine, and that is the low pressure turbine. This green part is called the low pressure turbine, and this low pressure turbine runs the low pressure compressor. So there are two compressors. That means compression takes place at two stages: low pressure compressor, high pressure compressor, and there are two turbines, low pressure and high pressure turbine. And this green shaft, you can see this green shaft is the concentric shaft. That is, it is coming through the high pressure turbine shaft. So around this green shaft there is another shaft. So it rotates within that space. From outside it looks like one shaft, but it passes through the bigger shaft, which is bigger shaft. This is for the high pressure compressor, and the concentric inner shaft is for the low pressure compressor. And there is one fan which acts like a propeller, but it does not have any propelling. It does not have enough propelling effect. And after this, whatever is left, that is expanded at the tail side, and this is the nozzle. So this part is nozzle part. Now I have already mentioned nozzle is a what? It is also a expansion device. So the pressure energy is converted to kinetic energy, and this is the jet of hot gases, and this is active force. The reactive force will be in the forward direction, and because of this effect, the jet moves forward, and that is why it is named as turbojet engine. So what is the components involved? The gas turbine produces what? Just sufficient power to drive the compressor. Whatever power is required for the compressor, that is done by the turbine. That means a fraction of expansion is completed in the turbine, and that power is utilized by the compressor. Of course, there are two turbines and two compressors. So total expansion does not take place in the turbines. After that, actual maximum expansion takes place in the nozzle. So we will get enough kinetic energy because of this nozzle expansion, and that will give us the jet, high velocity. It may be supersonic or sonic velocity of jet. The gases coming out of the turbine are expanded in the nozzle and produce a very high velocity jet, and this is the main cause of the movement, and it gives a forward motion to the aircraft by the jet reaction. Jet is action and reaction is forward motion. Okay, fine. So we also discuss today about the turboprop engine. You look at the name of the engine. So there will be turbine, turbo. There will be propeller because it is turboprop. That is combination of this. The combination of two things. First, screw propeller. It is like screw propeller as well as it is like turbojet also. Maximum energy is absorbed by the propeller, and that gives the forward thrust, as some energy is also given by the exhaust gases through the nozzle. So you can see there is one compressor and one turbine. And what does the compressor do? The compressor runs what does the turbine do? The turbine runs the compressor as well as it runs the propeller. So power developed by the turbine is used by the propeller as well as gearbox. So in the gas turbine, we may have discussed that a turbine runs at very high speed, and that much of speed is not required for the propeller. It is not advantageous to have very high speed for the propeller, and that is why there is one gearbox, and this is reduction gear. Okay, it reduces the speed of the propeller because the propeller get the power of the turbine through this reduction gear, and that is why the speed or RPM of the propeller is less, which is suitable for a jet engine. So this way maximum power is absorbed by the propeller and it gives the forward thrust, and whatever energy is left after expansion in the turbine, and this part is the nozzle part, and this nozzle also produces high velocity jet, but the effect of this jet is very minimum, but it has the effect. So we can understand the total power produced by the turbine is used to run the compressor as well as the propeller. Now this is the main thing. Propeller provides the most of the propulsive thrust. So propulsive thrust means forward motion, whatever power is required, maximum power is given by the thrust is given by the propeller. And thrust produced by the jet action is very small. Just now I have mentioned the jet gives some amount of thrust. It may be 80 is to 20. That means 80% of the propelling power is received from the propeller, and 20% of the thrust is received from the exhaust gases at the tail end when it passes through the nozzle, and that is why this name is turboprop there will be turbine, there will be propeller, some jet action will also be there. So this way turboprop engine works. So you need not go to the details of this. Now we have already discussed in the TS diagram how the expansion compression processes takes place. Now we take one example. Suppose this is a turboprop engine. Okay. So what is this? This is the propeller, and this part is jet. It is nozzle. This is turbine 2, and this is turbine 1, and this is the compressor. Now you just, we are representing air is entering into the compressor. That means air will come from the front side as usual in any propulsive device. So that will be compressed by the compressor, and then that will go to the combustion chamber, which will be combusted, and it will produce power in the turbine, and the turbine will run the compressor. This turbine T1, that means this is HP turbine. High pressure turbine will run the compressor only, and that is the yellow shaft. This shaft is connected to the compressor. High pressure turbine is connected only to the compressor. That means high pressure turbine produce small amount of power which is required to run the compressor. Now the exhaust from the high pressure turbine entered into the combustion chamber, second combustion chamber, and it is again burnt, and that way it will enter into the low pressure or second turbine, LP turbine. It will enter. Now LP turbine will also produce some power. It will produce maximum power. Although it is LP turbine, it will produce maximum power, and this power is transmitted through this shaft, which is a concentric shaft. This shaft passes through the yellow shaft, and this will go to the propeller. This is the propeller. Okay, so the propeller receives the power from the low pressure turbine. Okay, maximum power. So that will propel the engine mainly. Now whatever energy is retained in the hot gases, that will be expanded through a nozzle. So nozzle is an expandant device, I am telling repeatedly. So because of expansion also, that will also give some thrust to the vehicle. So this way we can represent this thing in a TS diagram. Say this is state 1, this is state 2, this is state 3, this is state 4, this is state 5, and this is state 6 before nozzle, and after nozzle says state 6. Now let's see how it can be represented. Okay, this is a TS diagram in which first you look at the compressor. What happened? It is the compressor. Say process 1, 2 is a compressor which compresses the air entering into the vehicle at the front end, and after that it is combusted, and this is a heat supplied process QS, and 2, 3 is heat addition process. So temperature will increase definitely. This is temperature T2. Okay, combustion chamber. After combustion chamber 1, it will go to the high pressure turbine, and that is a expansion process. Okay, this is expansion this is HP turbine. Okay, high pressure turbine produce the power required for the compressor only. That is enough. Now after that it will again go to the combustion chamber. Say this is combustion chamber 2. There will be again heat addition, and temperature will again increase. Okay. Then the low pressure turbine has to produce the power for the propeller. So this turbine will produce power W, and this work will be utilized by the propeller. Okay, propeller will utilize this power, this produce. Now after that there is a nozzle. So what is this? This is nozzle. Nozzle is an expansion device. In this case also there will be some power produced, but this is actually because of this nozzle we will get the kinetic energy, that is also an expansion process, and that gives the velocity to the jet, and reaction force will force the engine to the forward direction. So this way we can simply represent the processes involved in a jet engine, any air breathing engine, in a TS diagram. For any engine, it may be screw propeller, it may be turboprop, it may be ramjet, anything. Okay, I think this is enough for the jet propulsion for air breathing system. Now we'll understand a little bit about rocket propulsion. So difference with the air breathing system and rocket propulsion is that it will carry the oxygen, or we can say oxidizer, along with the vehicle, and also carries the fuel with it, definitely. So both fuel and oxidizer are contained in a container, and it is pumped to the combustion chamber. This is the combustion chamber. So with the help of a pump, two pumps, one is for oxidizer, another is for fuel, is sent to the combustion chamber, and where the combustion will take place continuously. And after combustion, pressure temperature increases, and that is allowed to expand in the nozzle, and that produces the jet. This is jet, active force. And because of the, as per Newton's third law of motion, it will push the vehicle in the forward direction, which is in this direction. So this way the rocket propulsion system works. This is only the basics of basics, okay? We cannot go beyond this. So in a rocket engine, fuel and source of oxygen, which we call the oxidizer, are mixed and exploded in a combustion chamber. They are sent to the combustion chamber and exploded. That better to say explosion, because explosion gives more power. This is not normal combustion actually. The combustion we used to know. Okay, the combustion produces hot exhaust which is passed through a nozzle to accelerate the flow and produce thrust. Okay, that is simple. Principle is very simple, although the work is very complicated one. That is why we used to say rocket science, no? Very complex thing. Many calculations and consideration has to be considered. Now rocket propulsion, this is a vast subject itself, so we have to know just what is rocket propulsion, what is the basic principle. So basically there are two types of categories of rocket engines. One is liquid rockets, that is also called chemical reaction rockets, and another is solid rockets, solid form. That means the fuel and oxidizer, or we can say propellant, is carried with the vehicle, and it may be carried in this chemical liquid form or in the solid form. Okay, so the first one is actually chemical rocket, in which the fuel and oxidizer are kept in the liquid form. They are combusted and allowed to escape through the nozzles. Okay. Then next one, in a liquid rocket, the propellants, the fuel and the oxidizer are stored separately as liquids and are pumped into the combustion chamber, where burning occurs. Now what happened for a solid rocket? In a solid rocket, the propellants are mixed and packed. That means there is one compartment in which the propellant are kept in a mixed form, and they will, under normal conditions, the propellant, although fuel and oxidizer are mixed, that they will not burn. Under special condition only it will burn. Packed into a solid cylinder. So there will be one solid cylinder, fuel as well as oxidizer. Under normal temperature conditions, the propellants do not burn, but they will burn when exposed to source of heat provided by an igniter. So there will be special ignition system which in this case is mentioned as igniter. This ignition can be done in many ways. So in this case, this is an example of electric system, by ignition by an electric system. And there is also one rocket propulsion system, that is electric rocket system. This is the fuel, and with the help of electrical spark or arc, like arc welding, the ignition is initiated. Okay, so electric rocket propulsion system is very good to give small amount of thrust. Sometimes when we send the rocket to the space, sometimes very little thrust is enough. If it escapes from the atmosphere, then there is not, because it escaped the gravitational field of the earth. At that time, a very little amount of thrust is enough, is so much in that sense. So in that case, in electric rocket system, that little amount of thrust, calculated amount of thrust, can be given by using this system. So it is very advantageous for space rocket and like this. So I think this is enough for our discussion, because at our level this is more than enough to know what is jet propulsion and rocket propulsion. Okay, thank you. So if you have any question, any question?